the third preparatory stage science course. I am Rania Hasabo and I am going to be your teacher here during this course. The goal of this work is not only for the exam, but also for understanding and linking information to the life around you. Wish you all the best of luck. Now let's start. Today our lesson is called mirrors. Mirror is a reflecting surface for light. There are some observations which we see in our daily life. If you look at a smooth shiny surface like mirror, you can see your image because light reflection. We see an image of the same object in the mirror because the light rays from the object bounce off the mirror and reach our eyes. So this makes that we imagine the light rays came from inside the mirror. This process is called light reflection. Light reflection means it is the phenomenon of the light bouncing off or returning back in the same medium when it strikes a reflecting surface. As the ball, when it strikes on the floor, it bouncing or returning back. From the previous, the light ray which strikes the mirror or the reflecting surface is the light ray which is fall on the reflecting surface is called incident light ray, while the other which bouncing off or returning back from the reflecting surface is called reflected ray, while this imaginary perpendicular line on the reflecting surface is called normal. So we found the angle between normal and the incident light ray. This angle is called angle of incidence, while between reflected ray and the normal is called angle of reflection. Reflection of light is governed by two principal laws. Law of light reflection. Number 1, angle of incidence equals angle of reflection. Number 2, incident light ray, reflected light ray, and normal all in the same plane, perpendicular on the reflecting surface. From this practical exercise, we can compare the angle of incidence and the angle of reflection. To do this, firstly draw a line on a piece of paper. Then place a mirror on the line where the glass in front of the line. Direct the light ray toward the mirror and make the path of the incident ray and the reflected ray by placing a dot on each of them. Using a ruler to connect the dots and form incident light ray and reflected light ray. Use the protractor to determine the 90 degree and can draw the normal. Then measure the angle of incidence and the angle of reflection, which always are equal. By protractor, we determine 90 degree and measure the angle from 90 degree toward the incident ray. This angle is called angle of incidence, which equal 35. Then also from 90 degree toward the reflected ray, it is the angle of reflection, which equals the angle of incidence. Repeat the previous steps by changing the angle of incidence and record the angle of reflection in each case. We notice that the angle of incidence and the angle of reflection always are equal. Consider this ray of light which strikes a mirror. This ray of light is called the incident ray. The point at which the incident ray strikes the mirror is called point of incidence. Draw a line perpendicular to the mirror through a point of incidence. This light is called normal. The angle which the incident ray makes with the normal is called the angle of incidence. There are two laws of reflection. The first one, the angle of incidence is always equal to the angle of reflection. If the angle of incidence is 30, then the angle of reflection will also be 30. Remember that these angles are always measured from normal, not from the mirror. The second law, the incident ray, the normal, the reflected ray from point of incidence, all in one plane perpendicular to the reflecting surface. According to the first law, if the incident light ray falls perpendicular on the reflecting surface by angle 0, it reflects on itself, because the angle of incidence equals the angle of reflection equal 0. The angle of incidence and the angle of reflection are always equal. Mirrors are divided into two main types. The first one is the plane mirrors and the second is the spherical, which is divided into concave mirror or convex one. We have a plane mirror convex mirror and concave mirror. Plane mirror has a flat surface, while convex mirror has a curved surface outward and concave have a curved surface inward. Place a card with some letter written on it in front of the plane mirror, which is fixed vertically. You can record your observation about the properties of image which formed on the plane mirror, which are upright or erect. Number 2, equal the size of object. 3, laterally inverted or reversed. 4, virtual image which can't be received on screen. Number 5, the distance of the object to the mirror equals the distance of image to the mirror. The last property is the straight line which connected the object and its image is perpendicular to the surface of the mirror. When we stand in front of a plane mirror, we see an image about ourselves in the mirror. The image formed in the mirror is virtual image, not real. While the image which formed on the screen, such as which produced by a projector, is real image, can be received on a screen. An image that can't be formed on a screen is virtual image that appear to be formed behind the mirror. Now again, the properties of image which formed by the plane mirror. Number 1, virtual image which can't be received on the screen. Number 2, erect or upright, not inverted. Number 3, image size is equal object size. When you look at a plane mirror, you find that the image which formed is laterally inverted. As if you raise up your left arm, you find that your image rises up the right arm. Left-right reversal. So the image which formed by plane mirror is laterally inverted. The fourth property of the plane mirror, the image distance equals the object distance. If you look at the candle in the plane mirror, you find that the distance from the object or from the candle to the mirror is equal to the distance from image to the mirror. The word ambulance is written in a laterally inverted way on the ambulance car. Why? Because the mirror of the car in front of ambulance form a laterally inverted image for this word, and thus it appears laterally corrected to the drivers. The second type is the spherical mirror, convex and concave. Stainless steel spoon is considered as an example of a spherical mirror, as its inner surface acts as a concave mirror and its outer surface acts as a convex one. You have observed a considerable difference between your image in the spherical mirror and your image in the plane one. What is meant by the spherical mirrors? The spherical mirror, it is a mirror whose reflecting surface is a part of a hollow sphere. There are two types of spherical mirrors, concave mirror and convex one. Convex mirror, it is a mirror whose reflecting surface is a part of the outer surface of the sphere. The concave mirror, it is a mirror whose reflecting surface or shining surface is a part of the inner surface of the sphere. Each mirror is a part of a circle of a sphere, and both of them have a center. This called center of curvature is represented as C. The distance between C and any point on the mirror is called the radius of curvature. It is the radius of the sphere of which the mirror is a part. While the point on the curve of mirror, which divided it into two equal halves, is called the pole, is represented as P. Now again, as P on the circle, the distance between C and B is called radius of curvature. While the line which passes through C and B is called principal axis. Principal axis is the line joining the pole of mirror to the center of curvature. Now, along this length, let's imagine a beam of light which has all rays parallel to principal axis incident on both convex and concave mirror. In concave mirror, the ray of the beam will be focused in one point. This point is called the focus and represented as F capital. It is the point on the principal axis at which the reflected light rays meet. In case of convex mirror, which diverged light, the rays of the light will appear to diverge from a point. This point is the focus of convex mirror. It is the point of collection of the extinction of the reflected light rays which fall parallel to the principal axis. So, we can say that the concave mirror has a real focus while convex mirror has a virtual focus, as the rays are backed around to meet at a focus. The distance between focus and the pole of mirror is called focal length, represented by small f, which always equal to half radius. F equal r divided 2 and radius equal to focal length. As the spherical mirror is a part of whole sphere, we have a lot of concepts. Number one, center of the mirror. The center of curvature is the center of the sphere which the mirror is a part of. Spherical mirror have only one center of curvature. Concept number two is the pole of mirror. It is the point in the middle of the mirror reflecting surface, and it divided the mirror into two equal parts. Number three, the radius of curvature. It is the radius of the sphere which the mirror is a part of it. Number four, the principal axis of the mirror. It is the straight line that passes by the pole of mirror and the center of curvature. As the mirror has only one pole and one center of curvature, so it has only one principal axis. Number five, the secondary axis of the mirror. It is any straight line by the center passes by the center of curvature and any point on the surface, except the pole. Number six is a focus, which it is the middle point between center of curvature and the pole of mirror. Number seven, focal length. It is the distance between focus and the pole of mirror. So it is equal half the radius, or radius equal to focal length. If the concave mirror is a part of a small hollow sphere, it has less focal length and considered as more concave. While if the mirror is a part of big hollow sphere, it has large focal length. We have three rules to determine the direction of the reflected light ray incident on the concave mirror. Number one, if the path of the incident light ray parallel to the principal axis. When fall parallel to principal axis, it reflects passing through focus. Number two, if the path of incident light ray passing through focus, it reflects parallel to the principal axis. Number three, if the path of the incident light ray passes through the center of curvature, it reflects back on itself. Here, the angle of incidence equals the angle of reflection equals 0, and the light ray fall perpendicular on the reflecting surface. Why this has happened to your image? How does the small bend in the plane mirror forward or backward causes unusual image in shape and size? Because the rays which are reflected may be reflected on itself or collected in one point or diverged from the convex mirror. Let's consider a plane mirror have a beam exactly perpendicular on it. As it has angle equal 90, this beam is called normal. So this beam incident by angle of incidence equals 0. So it reflected by angle of reflection equals 0 according to the law of reflection. Now it is time to do something slightly different. Let's make the mirror upward. The beam automatically formed angle with the normal as the surface is inclined. In which direction light reflected? According to the first law of reflection, it will reflected upward with the same angle. And if you make the mirror downward, the same reflection takes place and the beam reflects downward. Let's compare these mirror positions by arranging them one below the other, and also by switching the top and the bottom position. What do you have? Spherical mirrors, yes. We have two types of spherical mirror, concave and convex. Concave focuses light, while convex disperses light. So here the converging mirror is the concave one, while the diverging mirror is the convex one. Let's place both of them side by side and understand the properties of image which formed by each one of them. If we set up a plane mirror and move backward and forward, we don't see any change in the reflection process. But if we try the same experiment in front of the spherical mirror, what do you think will happen?